Okay, good morning, everyone. Today's lecture will be on Riccati equations. Okay, and so what do we mean by a Riccati equation? A Riccati equation, which I'll use the notation RE for, is any equation that can be written in the form dy dt is q1 of t plus q2 of ty plus q3 of ty squared. Okay. So if you look at this and you see, so Q1, Q2, and Q3 are functions of the independent variable, which I'm calling t here. And if Q3 is identically equal to 0, then this is just a linear equation. So this is only something new if Q3 is different from 0. Okay, and there's a little bit of a catch in the method. Basically, we want to find the general solution. To this Riccati equation. All right, so the catch is it's not so easy to do unless for some reason, somehow, you know one solution already, just one solution. And then we want to know all the possible solutions. Okay, so let's see. If we're going to suppose for some reason we know one solution, say y1 of t. Okay. All right, so the trick, so once you know one, then the trick is, or if I give you one solution of the equation, you set y of t to be the known solution plus 1 over v of t. Okay, and if we can find v, or a formula for v, then y1 plus v is the general solution of this equation. Okay, now you might ask why 1 over v, why don't you just call it v? Well, because the trick won't work very well. This is the trick that works on Riccati equations, as we are beginning to see. Then for this course, that you see a certain kind of equation, you want to know the trick that works for it. Okay, so if we've set y to be this, then let's begin to differentiate. We want y to solve the same equation. So y prime, and I'm going to quit writing function of t, okay? Y prime is y1 prime, and this is v to the minus 1. So when you differentiate, you get minus v to the minus 2. So this is y1 prime minus 1 over v, times v prime by the chain rule over v prime v squared. Okay? And y1 satisfies the Riccati equation. So we replace y1, since it's a solution of the Riccati equation, by q1 plus q2y1 plus q3y1 squared. And then we have minus v prime over v squared. On the other hand, we want y to satisfy the Riccati equation. So the right-hand side better satisfy this equation as well. So on the right, we need q1y, sorry, just q1, no y, plus q2y plus q3y squared has to be equal to q1 plus q2y1 plus q3y1 squared minus v prime over v squared. Okay, but y is given by y1 plus 1 over v. All right, so let's plug that in for y on this right-hand side. So we will get Q1 plus Q2 times Y, which is Q2Y1 plus Q2 over V plus Q3Y squared. So you have to square this binomial. Okay, so that means I have Y1, Q3 times Y1 squared plus 2Q3 Y1 over V. That's the product of the two, twice the product of the two, plus the square of the second times Q3. So that will be Q3 over V squared. So all of that was this right-hand side, and that's got to be equal to this left-hand side from the line above. So that is Q1 plus Q2Y1 plus Q3Y1 squared minus V prime over V squared. Okay. And now let's look and see what cancels and what doesn't. We have some cancellation. Okay, so let's see. We can see that we have Q1 on the right and Q1 on the left. That cancels. We have Q2Y1 on the right and on the left. Okay. We have a Q3Y1 squared on the right and on the left. Okay. So now we're left with just 1, 2, 3, 4 terms. So what does that say? That says that, let's see, that says that Q2 over V plus 2Q3Y1 over V plus Q3 over V squared is equal to minus V prime over V squared. So let's multiply by V squared and rearrange. Okay, so, and I'll write, instead of V prime, I'll write dV dt. So I'm bring this over here. So I'll have dV dt. So with a plus sign, bring everything else to the left, and I'm multiplying by V squared. So I will have a V times the terms minus Q2 minus 2Q3Y1, because there'll be when I multiply by V squared, I'll still have a V from these terms. When I multiply this one by V squared, I don't have any other terms, so I have a minus Q3. Okay. And now when you look at this equation for V, now remember, Q3, Q2 are given in the equation. Y1 is the known solution, so you know that. So you know everything over here except V and dV dt, and then notice this is a linear equation for V. So we can solve by the methods we learned a week ago. Okay, so once we know V and we know Y1, then we can come back and say what the general solution is. Okay, so that's it for Riccati equations. But the catch is you need to know a solution to start with. Here's the trick. So this is the important thing to remember when you see a Riccati equation. Here's the trick you go for. Okay. And then what that trick, you can either go through the derivation or on these tests, you can use your notes. V has to satisfy dV dt is this equation. So you solve for V, and then you go back and you substitute in to get Y, the general solution. So let's do an example. Okay, so there's our theory. Now let's do an example. Suppose I give you the equation Y prime minus 1 over t squared minus y over t plus y squared. And okay, so first of all, you notice this is a Riccati equation because you have a derivative is equal to a term that only depends on the independent variable. Then you have a term that's a function of t times y, and then you have a function of t times y squared. And actually, these functions are very easy functions. Q1 from our what we wrote before is minus 1 over t squared. The term that's with the 0th power of y. The term with the first power of y is what we call q2, and that is minus 1 over t. And the q3 is the coefficient of the squared term of the y squared term, and that's just 1. Okay. So our general solution, and suppose I tell you, suppose we are given that y1 of t equal 1 over t is a solution. All right, so I'll leave that for you to check. It is a solution, just differentiate it. You'll see it really does solve that equation. And now we're asked to find the general solution. Okay, so the first issue will be on a test on the midterm or on the final is to notice that this is a Riccati equation, so you know which method to use. Otherwise, if you use the wrong method, you're not going to get the answer, right? All right, so let's remember that the equation that V has to solve, and we met, well, first, let me actually set, so we set y of t equal to y1 of t plus 1 over v of t. And y1 is 1 over t. So this is 1 over t plus 1 over v of t. Okay, and this is where v satisfies. And I'll copy down the equation. Before you have dv dt, and I'll write it in its linear form, plus q2 plus 2q3 y1 times v is equal to minus q3. Okay, so that's what we had before, bringing the v term to the other side, because when we solved linear equations, we usually wrote the v term on the right-hand side so we'd know how our method works. Okay. All right, so let's write down the exact equation we have with our q1 and q2. Well, notice q1 doesn't figure in here, actually. So it's just q2, which is minus 1 over t plus 2q3 times y1. So q3 is 1, y1 is 1 over t. So this is 2 over t times b is equal to minus 1. And notice that this is just 1 over t. Okay. All right, so that's our linear equation. dv dt plus 1 over tv is minus 1. And how do you solve a linear equation? Okay, so you look for the coefficient of v, and your integrating factor is e to the minus integral of that coefficient function dt. Okay, so that is e to the ln absolute value of t. You don't need plus c, you just need one integrating factor, not every possible one. E and ln are inverse functions, so the integrating factor is just t. And now you multiply this equation by t. So I'm doing the method we learned earlier for linear equations. Okay, so multiply that whole equation by t. So I get t, and I'm just going to write it as v prime. And when I multiply by t, I just get plus v is equal to minus t. And then you notice that this thing is the perfect derivative with respect to t. Oops, ink issues. New pen. Fountain pens always have a little bit of ink issues. Wow. Okay. As the ink gets low. So dv dt of TV, because remember, when you have an integrating factor, if you've done everything correctly, it should be the integrating factor times the unknown function, the perfect derivative on that side, if you found the correct integrating factor, if you did your integration correctly. And that's equal to minus t. And that's a separable equation because you write it as t dv is equal to minus t dt. On the left, you have a perfect derivative. So you get back tv. When you integrate minus t dt, you get minus t squared over 2 plus c. Now divide by t. So I get minus t over 2 plus c over t. Okay. And since I'm going to need 1 over v, let's write this as a single fraction. So this will be 2t over 2c minus t, but this is just another arbitrary constant. So we'll just call it c. Okay. All right. So you get v is equal to c minus t over 2t. And so 1 over v is equal to 2t over c minus t. Okay. And then finally, putting that together, we can see our general solution is so move that out of the field of view. So the general solution is y of t is y1 plus 1 over v, which is 1 over t plus the v 1 over v we found before was 2t over c minus t. So you can leave it like that. You could write it as a single fraction, doesn't matter. Okay. So either way, it's fine. Okay. So here's your general solution. Y of t is equal to this. Okay. And that's it. That's all there is to Riccati equations. Again, you first have to notice the form of the equation. Notice that it's a Riccati equation. You make this substitution. And then the equation that you have to solve for v is this linear equation. You solve that linear equation, you get v, and now you put it together with the known solution y1 to get the solution to your problem y. And that's all there is to Riccati equations. Pretty simple once you recognize them. Okay, so that's it for right now. And see you soon in the next lecture. Bye.